Now we're in trouble. Now we're looking at solving a system of three equations with three unknowns. Now, we don't really spend a lot of time with graphing these and really trying to understand what they look like, but when you have an equation like this, we're typically talking about a plane. So when you're talking about graphing in 2D space and you have x and y, we're thinking about graphing a line. When you're in 3D space with x, y, and z, something with an x, y, and z term is going to be a plane. So when we think about what could happen if you have three planes out in space, well, you easily could have this the situation where there's no intersection. If all the planes are parallel to each other, kind of stacked on top of each other, there's no solution. Or it could be that they all intersect like this and then like this, where they don't all share the same points. That could be a problem. Then there is the situation where they all intersect and the intersection is a line. So that would be like me intersecting this and having another one intersecting underneath at a different angle, all intersecting having the same line. But typically what we have is we have something that is more akin to this. So we have a plane like this, and you have another plane intersecting over here, and then maybe you have, that's not what I meant. And then you have one, this is kind of hard to draw three-dimensionally. So then you have this one, so the intersection is going to be, where these guys all intersect right there. And that's kind of what we're looking for. So doing this with substitution, typically it's not going to be the best thing. Well, it all depends on how things are set up. But elimination is what we want to do. Now, what we have to do is we have to go from three equations with three unknowns to two equations and two unknowns. So in order to do that, we have to eliminate the same variable whenever we're combining two different equations. So a lot of times you'll see something like this. You'll see the textbook mark these equations as say 1, 2, and 3. Now if we do this, it might help us out here. If I say taking equation 1 plus equation 3, if I combine those two equations, you'll see that the z's are going to go away. So if I combine 1 and 3, that gives me 2x, y plus 3y is 4y, plus z minus z goes away, -2 and 0 is -2. And then if I combine equation 2 with equation 3, again, we'd get the z to go away. But we're doing this with a different pair of equations. So if I were to combine these guys, we get 2x plus x, which is 3x. -y plus 3y is plus 2y. Again, the z's go away. 5 plus 0 is 5. And so now we have a very nice looking system of equations. It's two equations, two unknowns, so we can solve this by using elimination or substitution. Now, I'd go for elimination. And looking at this system, probably the easiest way to do this is to multiply the second equation times -2. So the first equation stays the same, 2x plus 4y equals -2. Distribute the -2, -6x minus 4y equals -10. All right, the y's reduce. We end up with -4x, -2 and -10 is -12. Dividing both sides by -4 means x equals +3. So this is not our answer. This is just the first part of the answer. Once we have 3, then we work our way backwards to find out, well, because of the system that we have right here, that's x and y, we know x, let's find y. And then once we have y, the only thing we don't know is z. All right, so I'm going to take the equation here, 3x plus 2y equals 5. Let's see what we get. So 3 times 3 plus 2y equals 5. 9 plus 2y equals 5, so that means 2y is -4, and y equals -2. Again, it's not my answer, it's going to contribute to my answer. The last thing we need to do is figure out what z is, and it doesn't matter which of these equations you choose. Now, for me, I'm going to choose the top equation. It looks pretty simple, x plus y plus z. So let's write that x plus y plus z equals negative 2. So we have x is equal to 3, y equals negative 2. All right, so that means 1 plus z equals negative 2, so z equals negative 3. Put all of this together and write your ordered triplet. So when you just have 2 coordinates as an ordered pair, 3 an ordered triplet. Go figure. And it has to be in the order x, y, z, just like that. Take the time to check your work. It doesn't take a lot of time to check it, and it's going to be very, very helpful to you. So from the first equation, like, we should already be fine. You can see that, I got the negative 3 by using the first equation anyway. So if I plug in, the 3, negative 2 minus 3, that's going to give me negative 2. For the other ones, just take a moment here and work that out. Actually, I want to slide this up a little bit. We don't need this graph anymore. Goodbye. So I would have 2. We said our x was positive 3 minus y, which is negative 2, plus negative 3 for z. 6 plus 2 minus 3 does equal 5. Okay, so we know the second equation checks out. The third equation, x is 3, y is negative 2, z is negative 3. So we end up with 3 minus 6 plus 3, which does equal 0. So it doesn't take a long time to check our work, and we really need to make sure that we do that. That way we know beyond a shadow of a doubt if the answer that we have is correct. Now, in some later videos, we're going to be showing you how we can really check this and actually have the calculator do all the work for us, but we're not going to do that just yet. We're just going to do a few more examples to make sure we really understand how to work with solving systems of 3 equations and 3 unknowns.